My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 210. In this lecture, we will try to understand equation of a line in two-dimensional space, equation of a plane in three-dimensional space, and hyperplane in n-dimensional space. Since we just learn about the vector, I already discussed about vector in my previous lectures, that is in lecture number 209 and 208. Let's go slightly ahead and understand next big idea called line. This one is important, isn't it? It may not sound very big, but let's see how the idea inspired. When we look at 2D, 3D and high dimensional spaces, so let's look at what a 2D. Suppose, let me say, first we will try to understand things in two-dimensional spaces. In 2D, as I told you, we will discuss about line in 2D. Suppose this is your x1 axis, this is your x2 axis. If you remember your 10th grade maths or 11th grade maths, we always wrote our line as y equal to mx plus c. If this x1 equal to x and x2 equal to y, just it's for my convenience, instead of writing x and y, just I am writing x1 and x2. It's nothing more than that. It's simple notation. Whereas in the case of y equal to mx plus c, what is this m? This m is slope, isn't it? And what is the c? C is the intercept. C is the intercept on y axis. Your line may be like this, y equal to mx plus c, where m is slope and c is the intercept on y axis. There is other equation of the line. You can write line in this form also, in general form of the line. I can write line equation as ax plus by plus c equal to 0. This is called general form. This one I can call, this is called general form and equation. This is called general form of an equation for line. I can say of an equation for line. If and they both are equivalent, you can prove it. This y equal to mx plus c, if I say let it be 1, this ax plus by plus c equal to, actually they are equivalent. Why? Because this ax plus by plus c I can rearrange in the form of y equal to mx plus c. How can I rearrange this? Y equal to ax plus by plus c equal 0. I can rewritten as y equal to minus c by b minus a by b into x. I can write it is of the form y equal to c plus mx, isn't it? What is c here? C is minus c by b, and what is my m? M is minus a by b, isn't it? Therefore, I can say ax plus, let me rewrite, I can say ax plus by plus c equal to 0 is called general form. I can say this is general form. Whose general form? General form or general equation or the general form of a line. I can say it's a general form of a line, isn't it? It's an equation, isn't it? We will stick to this notation. Which notation? Instead of y equal to mx plus c, I will stick to this particular notation ax plus by plus c equal 0. This is much general, isn't it? If my axes are, let me say, I am assuming this one is x1 axis and this one is x2 axis. I can rewrite if your x-axis is x1 and your y-axis is x2, this can be rewritten. Which one? Ax plus by plus c can be, I will rewrite. How can I rewrite? I must say, instead of, in the place of x, I must write x1 in the place of y, as in the y-axis means here x2 axis. I must write bx2, ax1 plus bx2 plus c equal to 0. Can I write like this? Yes. Instead of using a comma b comma c, let me, I am using a, b, c, isn't it? Instead of using a comma b comma c, let me use different notation, because if you want to do it in 10 dimension, how would it, how will I write? Maybe if I want to work with 100 dimensions, I cannot write a, b, c, d, e, f, g, h. It's a little bit difficult. I don't have to use all alphabet for all these 100 dimensions. I don't have enough alphabets. For example, there is 1000 dimensional space. I cannot keep on writing a, b, c, d, e, f like this. Why? Because I don't have enough alphabets. So I can write this one as this ax1 plus bx2 plus c equal to 0. Let me write like this. I will write like this: w1 x1 plus w2 x2 plus w0 equal to 0. Now this may be a little bit convenient form. If there are 100 dimensions, I can keep on writing w1, w2, w3, so on, w100. Whereas it's difficult to write with the letters a, b, c. It's a matter of notation. It's nothing more than that. If x1 and x2, x1 is on x-axis, x2 on y-axis. Instead of using a, b, c, here I am writing, I can say like this: instead of a, I am writing w1, isn't it? Instead of b, I am writing w2, isn't it? Instead of b, I am writing w2. Instead of c, I am writing w0. Just see. Instead of c, I am writing w0. Now this w1 x1, what is this equation? w1 x1 plus w2 x2 plus w0 equal 0. Let me say this is equation 1. Let it be 1. Equation of the line, where it is, this is equation. This is equation of the line, isn't it? It is equation of the line in 2D. What are the axes? x1 axis, x2 axis. What about 3D? This is about 2D. Now how can I write equation? What about 3D? In 3D, how many variables we can have? We will try to understand about 3D. Yes. If you want to write an equation in 3D, how can I write? Just see, how many axes do I have here? Just see, this one is my x1 axis. This one is our x2 axis, isn't it? And this one is x3 axis. What we are doing here, let me write first w1 x1 plus w2 x2 plus w0 equal to 0. What about this? This is in 2D, means that is line. Now what about 3D? I have 3 axes: x1 axis, x2 axis and x3 axis. The equivalent of a line in 3D is plane, isn't it? In 3D I can say it must be a, in 3D it must be a plane, isn't it? In 3D it must be a plane, and equation of the plane looks like, what is the equation of the plane? Equation of the plane looks like, you might have learned this equation in your primary classes. Just let me recall. How can I write AX? Plane means you may have something like this. You can write something maybe something like this. This is a plane, isn't it? Now, equation of the plane may looks like ax plus by plus cz plus d equal to 0. Can I write like this? Ax plus by plus cz plus d equal 0. Let's generalize it. How can I generalize this ax plus by plus cz plus d equal 0? Can I write like this? w1 x1 plus w2 x2 plus w3 x3 plus w0 equal to 0. Can I say like this? This is, let me say, this is second equation. This is first equation, isn't it? Now, what first one is, what is this one? I can write one is a line. It is in 2D, line in 2D, two-dimensional space. Whereas 2 is plane in 3D. 2 is a plane in 3D. Can I say like this? This is simple and straightforward. The equivalent idea of a line in 2D in 3D is plane. My immediate question is, what about n-dimensional space? What is it called? What is it called in n-dimensional space? In 2D we are saying line, in 3D we are saying plane. What about ND, in n-dimensional space? How you will call? That is nothing but hyperplane, isn't it? That is, how can I call that corresponding one? Hyperplane. Hyperplane is ND. Hyperplane is generalization. Hyperplane is basically a generalization of the concept of a line or a plane to higher dimensions. We are generalizing line to plane, plane to hyperplane. Because if you think line is called a linear surface, but it separates your whole region with this with simple linear structure like a line or plane into two regions, line in 2 dimensions, plane in 3 dimensions. It is used to separate points, isn't it? Anyway, I will spend a lot of time how it can separate. On one side of the line you can find one type of points, on other side of the point you can find other type of points. Plane can separate your 3D surface, your 3D volume into 2 regions, one above the plane and another below the plane. You may have some sort of points above the plane, you may have some sort of points below the plane. Plane can be used to separate the points in 3 dimensions, whereas line can be used to separate the points in 2 dimensions. So the immediate question is, what is the equation of a plane in n dimensions? Suppose if I have n dimensions, what is the equation of a hyperplane? You could have easily understood that by just looking at the form of this. How can I? Let me rewrite this one. Otherwise, let me rewrite. I will write. Just see. How can I write? W1 x1 plus W2 x2 plus W0 equal to 0. Let me say this is my first equation. This is it is in 2D, that is line, isn't it? Now, what about this one? W1 x1 plus W2 x2 plus W3 x3 plus W0 equal to 0. I can say like this. This is equation 2. I can say it is in 3D, 3 dimensions. This is 3D, isn't it? In 3D, how we are calling that one as plane. Now, just let's extend it and see what will it be in n-dimensional space. In ND, how can I write? Let me write like this. W0 plus W1 x1 plus W2 x2 plus so on Wn xn equal to 0. Let me say this is equation, let me say let it be 3. This is the equation of an n-dimensional hyperplane. This is equation of, this is in ND. I can say this is in n-dimensional, it's n-dimensional. I can say this is hyperplane. Which one is hyperplane? This W0 plus W1x1 plus W2x2 plus so on Wn xn equals 0 is hyperplane. Now the immediate question we get is this. This is too cumbersome to write. Maybe it's a little bit complicated to write this big equation W0 plus W1x1 plus W2x2 plus so on Wn xn equals 0. Maybe it's a little bit cumbersome, isn't it? It's a little bit difficult. Is there a more concise way of writing this? But of course, there is. We can use summation. How can a summation notation? How can I write that using sigma notation? Can I write like this? W0 plus sigma I equal to 1 to n wi xi equal to 0. Let me say this is fourth equation. Just I equal to 1. If I keep I equal to 1, w1x1 plus I equal to means w2x2 plus so on wn xn equal 0. Is there a better way to write this? Still this is good. This particular notation is it not good? It's a little bit good. This is certainly much more, this fourth equation is much more concise way of writing the equation of a hyperplane in n-dimensional space than writing this whole expression. Instead of writing this whole expression W0 plus W1, instead of writing, if you write, this is more concise way. There is a slightly more interesting way of doing it, which is, I can write it as, can I write it W0 plus I can write something, isn't it? If I create a vector, let me say I will create a vector. I will create a vector W. Let me create a vector W. So those of you who remember how to multiply two vectors or multiplying matrices, you will quickly recognize this. Let's assume I have W equal to W1 comma W2 comma so on Wn. Let me write like this. Imagine I have x1 again a column vector x1 x2 so on. Let me write xn. I have this another vector, isn't it? Now how can I write this my hyperplane equation? Can I write like this? W0 plus, just observe carefully, what is my, just a second, yes, let me erase this one, otherwise I will write here. Let me write like this. Yes, let me write like this. W0 plus, what is my W? Can I write like this? W1 comma W2 comma so on Wn. Can I write this one? Into what is my vector? x1 x2 xn equal to 0. Can I write like this? Yes, I can write like this. Just this is nothing but a vector notation. I can say this notation is, this particular notation is, I can say vector notation. Which notation? Vector notation, isn't it? Yes, it's a vector notation. It is some first one, that which one? This one, fourth one. I can say this fourth one. This one is which type of notation? I can say this is summation notation. Same thing we are expression in different ways, summation notation. Can I say like this? This is summation notation. I am not changing any formula here. I am just changing the notation slightly. So what does this product look like? So when you multiply, this is nothing but just multiply. Can I multiply this? How many rows? There are 1 row and n column, isn't it? This and n rows and 1 column. Number of columns in first matrix is equal to number of rows in second matrix. Therefore, matrix multiplication is possible. Immediately after this, if you multiply, what will you get? Just see, the same equation you will get. W0 plus W1 into X1. This is vector product, or you can matrix multiplication, plus W2 X2. Isn't it? W2 X2 plus so on Wn Xn equal to 0. Can I say like this? This is just like a dot product. We will write this in much more concise form using vector notation. I can think, let me rewrite things here. Yes, just 1 second. Yes, I can think this vector W. Let me write this one. I can think W1 comma W2 comma so on Wn as a vector W, This is W, I can say, isn't it? And this another vector. What is that vector? X1, X2, so on Xn, isn't it? Xn. Think this one as X. Let me say this is X vector. Therefore, how can I write this W0 plus W1 comma W2 comma so on Wn into what will I write? X1, X2, so on. I can write Xn, isn't it? Is equal to 0. This is anyway 1 cross n. This is anyway n cross 1, isn't it? This vector X has n rows. Just see, n rows and one column, isn't it? It has only 1 column. This vector W has 1 row and it has n columns. If you recall the matrix multiplication, you can multiply 1 by n with n by 1 to get 1 by 1 matrix, means I will get a scalar, isn't it? We look at a plane or hyperplane in n-dimensional space. We look at many properties of lines and planes in the next few lectures. Just while ago, we realized that the equation of a plane in any n-dimensional space is this one. This W0 plus W1, W1, W2, Wn, this one I can write. So I just told you a while ago that given any vector, if I write a vector W, in my previous lectures, if I write a vector, if I write a vector by default, just recall, by default it is row vector or column vector? By default it is column vector. By default it is column vector. If I say I have a vector W which is of n dimensions, by default convention is, this is just for a simplicity to avoid confusion between whether a given vector is a row vector or column vector. So the default notation is that I have n rows and 1 column. My default notation, if I say W is a vector and X is a vector, I can say, let me say W comma X are vectors. What is your default notation? Once if I say vectors, they are column vectors, isn't it? Therefore, I can write W as n by 1. How can I write? By default, as they are column vectors, I can write W1, W2, so on. I can write Wn, isn't it? What about X? If I say X is a vector, by default, it is a column vector. I can write it as x1, x2, so on. I can write it as xn. Using this, my w and x, which are n-dimensional column vectors, how can I write this equation little more concisely? I can write it as, let me write this equation again, let me rewrite this one, w0 plus w1 comma w2 comma so on wn into x1, x2, so on. I can write xn, isn't it? Xn is equal to 0. As I told you, my w is a column vector by default. X is also column vector. Can I write like this? W0 plus this basically original w is column vector. I need row vector. Therefore, I must write w transpose. If I write w transpose, I will get a row vector w transpose into capital X equal to 0. This is one important form. This I can say my w0, I have just copied w0 since w is a column vector. Just I copied w0, isn't it? W is a column vector. I need to convert it into row vector, isn't it? How can I convert into row vector? How do I convert a row vector into column vector? I just applied transpose. W transpose is nothing but what is W transpose here? Here W is column vector, W transpose is row vector, and your X is column vector, which is exactly like this. So what I have here, a clumsy format, I can say I have just concisely, you can write a concise notation, W0 plus W transpose X equals 0. Is it not hyperplane equation? Of course, my W is a column vector, isn't it? Similarly, my X is also column vector. So, if you write the equation of a plane again, planes are typically written with a capital letter. Planes are typically write with pi notation, pi, isn't it? People used to write pi. A plane pi in any dimension can be in n dimensional, and I can write a plane pi n. I can write it as w0 plus W transpose X equal to 0. This is the equation of the plane in n-dimensional space. I can say it is equation of the plane, equation of the plane in n-dimensional space, equation of the plane in n-dimensional space. Just understand these n-dimensional space. Just understand this notation. This form W0 plus W transpose equal to 0. This is important notation. We will use this one in many that may be in support vector missions, that may be in logistic regression. We will discuss this form. Try to understand this particular form W0 plus W transpose X equal 0, so that you can understand whether that may be support vector missions, that may be logistic regression. For that matter, there are many machine learning algorithms or data science algorithms one can understand without any difficulty. I will continue my discussion on this on the same topic in my next lecture, that is in lecture number 211. Thank you very much.